Well, hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, I want to test out this Apple Profile hard drive. The Profile hard drive was first released for the Apple III, I think around 1981 or 82, something like that. This was designed to plug into an interface card inside the Apple III, and the original versions of this were 5 megabytes inside, and the later ones were 10 megabytes. I don't know anything about this one, like how big it is, because this was given to me in completely unknown condition. And I've had this for a number of years and I've never gotten around to testing it because while I have an Apple III and I have the profile card for it, I don't know. I haven't used the Apple III in a while. And I figured this was as good a time as any to test this hard drive because the Apple Lisa also uses a profile hard drive. Now the Lisa came out in 1983, so a couple years after this drive I think was released. So this drive was definitely released to come out and coincide with the Apple III, which the design language of this, it actually is the same size as the Apple III itself. So it can sit on the Apple III and then you can put the monitor for the Apple III on top of this. That's the why this thing looks like it does. But the Lisa, well, this thing could just sit on the top of the Lisa or off to the side of the Lisa or whatever. And the Lisa pretty much requires a hard drive. Maybe the Lisa 1 was able to work without a hard drive, but the Lisa 2 and the Lisa, well, 2/5, which is the one that uses the 5 meg external hard drive, or the Lisa 210, which has an internal version of this drive, the Lisa OS, or sorry, it's called Lisa Office System, LOS, Lisa Office System. It requires a hard drive. I think it's like 5 or 6 3.5-inch hard drive or floppy drives, 400K each. Anyways, I need to install another drive. So long story short, I need to know if this drive works. Now the funny thing is about this drive, I said it was just given to me randomly. I don't know anything about it. The person who gave it to me had no idea about it either. And while the condition of this is actually really nice, like it's not really yellowed and it's just a little bit dirty, but I've had it for a few years. The biggest issue is if we turn this around, there were some plates that covered these two openings and they're missing. In fact, when I got this thing, it was completely disassembled. None of the fasteners were in it, so it was just all loose. Everything was all taken apart. I don't know why. I don't know if it was broken. This was like spare parts taken for other stuff. But that is a hard drive that you can just make out. Let's zoom in a little bit. Someone wrote a 5 on there, so kind of implies that it's a 5 meg drive. This is a Seagate hard drive, I'm pretty sure. I think it's an ST506, and Apple bought these from Seagate and either without the drive electronics or they threw away the drive electronics and they built their own. So over here on this side is a 25-pin connector, and then there's the main PCB, which has a CPU on there. I think it's a Z8 CPU, which is like a Z80, but it's an embedded version. I think it has built-in ROM inside the processor itself, like mask ROM, and that's what's on this board. Of course, it also has a power supply, and there's an on-off switch here, so I think it's a switch mode power supply. And it looks like I've actually serviced this at some point in the past because I said replaced refuzz, 12/2024, noisy drive bearings, solid red LED equals passed self-test. So as I mentioned, I never tested this with the Apple III and I didn't have a Lisa to try it on, so I just simply powered this up and let it run, and apparently it has some self-test routines. This is what people told me, and it seemed to pass those routines, which is a great sign because maybe this drive actually works, and I could show the Lisa working with it as it was designed to do. Now flipping down to the front, we can see there's the bottom of the hard drive. There's another cover that I think is supposed to be metal, and that's also missing. And I had, like I said, the fasteners were all missing, so I found some screws that sort of held it all together, and the drive is actually screwed in there, so that's good. It's not just floating around. The bottom of the Seagate drive, there's an Apple computer logo there, so it tells us that, like I said, this drive electronics board was designed by Apple along with the main controller PCB. And well, yeah, how Apple is that to just not use an off-the-shelf hard drive with ST506 interface, which is like MFM, what we call MFM, and then build a board just to talk between the parallel port that goes to the Apple III or the Lisa and the MFM drives? No. How about just redesign it all entirely? And it's funny because I think this was a 5 meg hard drive with ST506 interface, and it's still a 5 meg hard drive. So it's not like it increased the capacity. If you could hold 10 megs on this 5 meg drive because of fancy encoding, sweet. But no, that's not the case. It is my presumption that on these plates that are missing, especially on the back, there was probably model number information, hard drive size, stuff like that, but there isn't. Now for testing this, I'm not quite ready to test with the Lisa. So in this video, I'm going to test with this. If I flip it around in the correct way so the electrons don't fall out, this is the ESProfile. So it's a profile drive emulator, but also a diagnostic device for profile hard drives like this, designed by Alex the Cat, who was the same person who gave me the power supply and some of those blank PCBs and has been helping me so much with this Lisa restoration. This thing is great because the primary function I'd want to use this with is hooked up to the Lisa. It doesn't actually work with the Apple III, this emulator, but well, it's a firmware issue, by the way, not a hardware issue. But hooked up to the Lisa, there's an SD card slot, and you can copy all sorts of hard drive images onto it, and then say boot the Lisa OS or Lisa Office system, that is. And well, you don't really need one of these noisy hard drives. And the best thing is you can have much larger images than the 5 or 10 megabytes maximum size that, of course, you got with this. The biggest thing for me is these are super noisy. These drives are very, very noisy. I'm personally not a fan of the really noisy drive bearings of older hard drives. I know a lot of people brings back some nostalgia, but something like the Apple Lisa is a very quiet machine if it wasn't for the very noisy hard drive that would be hooked up to it. So using one of these emulators means that you don't have to listen to that. Of course, for this video, what I want to do is power this thing up, make sure it's still passing its diagnostics, because what is solid red LED equals self-test passed. And then we can hook this up. And even better is using this, I can dump the contents of this hard drive over a serial connection, over the USB port, so that we could take a look at it and see maybe what system this was from. This could be Macintosh OS that was designed for the Lisa XL line of series, line of computers that is, when they had their updated ROMs and stuff like that. Or this could have been used on an Apple III. And this has got some Apple III ProDOS OS on here. The reason I'm making this video ultimately is just I want to show that open source tools like this can be very useful for testing and troubleshooting profile hard drives. So before we get started with the ESProfile, let me power this drive up and make sure that the ready light becomes solid, just to say that the drive is happy. Because if this drive is not working, like I can't get it working, well, this is going to be a different kind of repair video. One caveat before I power this up is it will be very loud and it will be picked up by my microphone, so I apologize for the audio issues. The compression, normalization of the audio in my videos will make the hard drive kind of sound weird. I don't think it will be that annoying, but it might be, so sorry about that if it's annoying. All right, I'm going to power on the power strip that this is plugged into. Here we go, 3, 2, 1. Okay, here it goes. I'm going to put the microphone next to it. It seems to be working. You're getting little blinks of the ready lights. I think that's normal. It sounds like the drive is seeking just slightly as it does this. I recall this process is relatively slow. It takes a little bit of time. I think when it's plugged into a computer, it actually doesn't run this self-test. This is only happening when it's not connected. Although I have zero experience with these drives. This is the only one I've ever touched, so I don't know much about it. But people more familiar with these have told me that the Seagate mechanism that's in here is actually quite robust and very reliable. Amazing for a hard drive designed and, well, released to the public in 1981 or 82. I doubt Seagate ever thought someone would be using one of their drives like 40 plus years later, like it's happening here, and yet still working. And we have plenty of hard drives that are newer than this that went bad. There it is, solid red light. All right, so I guess this thing is still actually working. Before I go testing this device hooked up to the hard drive, let's take a look at the GitHub repo. So this is Alex's GitHub repo, and here's the ESProfile, a powerful ESP32-based emulator and diagnostic tool for profile and widget hard drives. The widget hard drive, that is the internal 5¼ inch full height hard drive that's in the Lisa 210. I think it was only ever used in the Lisa 210. It's hard to believe, and I'm sure people who are familiar with Lisas know this, but I didn't know this, that Apple fully designed the widget hard drive, not just the controller. Like, they didn't just buy a Seagate drive and throw their controller on it. Apparently, the entire hard drive is designed by Apple. Everything. And the drive electronics on the widget, I think it's got multiple PCBs on there. It is essentially a profile hard drive with the big Z8 processor and everything all condensed down onto one hard drive. And it uses the same interface as the profile. It's just a parallel port interface designed to plug into the parallel port of the Lisa. It's an internal drive, so the routing of those signals is inside the Lisa on the ribbon cable, but ultimately it is the same signaling as, say, this emulator and this hard drive I have on the bench. Anyhow, back to the repo. Powerful ESP32 based emulator. Oh, incidentally, this was given to me by a local friend of the channel, Super SVGA. Thank you very much for that. This was funny. It was a while back, before I think I got the Lisa. This was given to me as well, because Super SVGA knew that I had a profile hard drive that I need to test, this one that we're testing right now today. But it's just so funny because this is going to come in super handy for the Lisa itself, so I can get that thing running some OS, well, full Lisa office system, hopefully, and other things that the Lisa can do too. Like, anyhow, it looks like Alex first designed the Arduino file, which was an Arduino or probably a ATmega based profile emulator, and later was updated to be running on this ESP32, obviously a lot more powerful. And it says here, the Arduino file would often fail to work when connected to a Lisa 210, parallel card, or accelerated Lisa. There's an accelerator for the Lisa that runs Mac OS on the Lisa, like Mac whatever system, whatever, much faster than the stock speed of the Lisa, which is like 5 megahertz or whatever it is. The ESProfile can handle all of these configurations with ease. So the ESProfile diagnostic mode is much improved over Arduino files. You can send pretty much any command in the profile command set, including all the 5 megabyte diagnostic Z8 commands, 10 megabyte Z8 commands, and widget specific commands in a nice user-friendly way. Arduino file only supported a select few and couldn't help you a whole lot with your 10 meg profile or widget. The ESProfile is capable of low-level formatting both the 5 and 10 meg drives, as well as the widgets, which is probably something that's quite useful, because I have found with some old ST506 based hard drives, like even Seagates, like ST225s for instance, a lot of times they don't really work properly, but low leveling them, it kind of makes them work again. It almost feels like over time, the magnetic flux that's written onto the disk actually fades a little bit and maybe gets a bit weaker than the read amplifiers can properly read. So on the connected computer, you often get hard drive failures and like read errors and things like that. Just low leveling the drive, which completely writes down an entire new structure onto the disk, kind of erases and rewrites everything down to a lowest level, seems to bring the drive back to life. I've had a lot of drives work perfectly after a low level format, but before that, all sorts of errors were happening. And I wouldn't be surprised, based on what Alex is saying here, that that's the case with this as well. I'm kind of guessing at the whole magnetic flux weakening over time. I don't know if that's really happening or there's some other reasons for low leveling fixing it, but that seems to be my experience with normal ST506 drives hooked up to a PC. And obviously, with the normal ST506 interface, the MFM interface, you can low level the drive from the disk controller. Like, that capability is just there. You just have to run the DOS program to do it. But since this drive is using this custom Apple controller, we have to issue some commands to actually do that low leveling format. Scrolling down a bit, Alex talks about how the ESProfile works with the Lisa, but not the Apple II and the Apple III. Yeah, actually, I forgot to mention the Apple II has a profile adapter card as well that Apple released. So you could use these profile drives on an Apple II with ProDOS. And Alex goes on to say that basically with the Apple II, it does not work. And it seems that it does not work on the Apple III as well. Thanks to using DMA for profile data transfers, the Apple III boasts the fastest transfer speeds of any profile capable computer. So it's possible that it's just too fast and the ESProfile can't keep up. How funny that like the 1981 computer is faster than the Lisa. That's kind of hilarious. Alex really goes into great detail on actually using like JLC PCB to do the building, and it is all open source. All the Gerbers are available, and if you really wanted to, you could just build one of these up on a prototype board as well. There are even STL files available for a nice case. That's really cool. Oh, and mounting it directly inside the Lisa. Very slick. That would especially be important on the widget versions of the Lisa 210, not something that I have, so I can't do this. It has to be external. Well, I could mount it internally. I just have to kind of make some custom wiring off of the bottom of the motherboard. And there's a whole section on loading the firmware. Super SVGA has already loaded the firmware onto this, so I don't need to worry about that. There are two different modes this can run in, emulator mode or diagnostic mode, I think it's called. And there's a switch, a physical switch on the board. So you just select which one you want. When you're in emulation mode, there's a selector application that allows you to pick which hard drive image you're using on the Lisa. And this is pretty cool. So it's using some commands to talk directly to the emulator, allow you to boot this boot menu, and then you can pick exactly which image you want. So if you want to boot to Unix or back into Lisa OS or LOS, then you can. So very, very sweet. Now here's the main menu, which we'll take a look at in a second. And this is when you're in diagnostic mode, this thing becomes a COM port on a PC and serial port on any other system. You just connect to it and you should be able to get to this menu. And it looks like there's all sorts of stuff you can do. You can test the drive. We can write buffer to entire drive. We can write zeros to the drive. Hey, search entire drive for a string, backup entire drive. Now this uses X modem to actually transfer it over the virtual serial connection. How cool is that? And then you can restore a drive from a backup as well. So perfect. I think what I want to do is get this hooked up to this drive, run the diagnostics, make sure that I'm able to talk to the drive from the diagnostic emulator. And then I would like to try to transfer the entire content from the drive, hopefully, into my PC, and then we can take a look at it. Not to mention, then I can low level this drive again. I could even restore the image if we look at it. It looks like a Lisa OS thing, or not. I don't know. It could be something really interesting on this hard drive. I mean, who knows, right? It looks like there's a bunch of other test commands we can run for like the servos and stuff like that, which is excellent because it seems like that diagnostic this does is pretty minimal. Random reads, random writes, butterfly reads. And then we have some specific commands for each of the models. And like I said, I think this is the 5 megabyte version. And it looks like in this menu, this is where that low level format option is, which is perfect. And this is what Alex says about low leveling. This often fixes drives that produce a lot of read-write errors, or even when the drive can't access disk at all. It consists of 3 steps. First, the format step, which does the actual low level format itself. And then we perform the scan operation, which scans over the surface to check for any defects that are still there after formatting. And then, of course, I would imagine it can map those out. It takes a minute or two, then executes the init spare table step, which creates a new spare table on disk, updating with any defects that were found during the scan. In order to execute the format step, a jumper must be installed in the profile digital board, bridging 2 pins, on header P7. So install and remove the jumper when prompted. This format operation is easy to use, but if it fails and you want verbose information, blah, blah, blah. Okay, well that means I guess I have to open the hard drive up. And I mean, there's a whole bunch more stuff, but we don't need to go read through the rest of this. I think I have all the info that I need. Okay, well, let's open this hard drive up. Let me just make this a bit bigger so I can see what I'm doing. Let's open this up. I had it powered up, plugged in. We don't need that. Let's open it because we got to take a look at that digital board on the top, which is not this one, it's the one on this side. And like I said, I'm really glad that this thing does work. I have to see how to open this, actually. I can't remember, since I did put this back together. I think these fasteners, these will let me take the top cover off, if I recall. Yeah, when I was given this drive, not only was it completely taken apart, but every screw was gone. So I had to guess on what screws to use, or whoops, screwdriver just fell in there with the screw. I had to guess on what to use. Okay, so back ones are off, but there must be screws on the top or front edge that I have to remove. Oh yes, probably these ones here. Yeah, so as I said, I'm trying to talk at the same time as making videos. I had to guess on which fasteners to use, and luckily I was able to find some that seemed to go in. Okay. There are the 3 front screws. There is a fastener that's inside the case now because there it is, popped off. Okay, we can unplug the light. And here is the fastener that popped off the front. So there's our digital board. That's the Z8 CPU, I assume, and a bunch of logic. That must be the jumper, P7, I think that Alex mentioned. It says it will prompt us when that is necessary. Just checking everything here. It looks good. It has a little bit of corrosion in here, but this thing is old, right? Let's look for date codes while we're here. 1986. Oh, this thing is way later than I thought. 1986 again. Okay. This one's 84, but that's in a socket, so who knows? These are 85. All right, well, this one is soldered, and it's 86, 10th week. So that tells us that this is kind of a late model profile hard drive. And then there's the hard drive itself, ST506. This is definitely a 5 megabyte hard drive. Yep, I think the 10 megs are Seagate mechanisms as well, actually. It's not the widget drives, but the profiles that are 10 megs. And it's a ST something else, different model number. Now, incidentally, this was not me. Someone wrote good on here and opened the screw, and that was not me. I did not take any of the fasteners out. Are there any other stickers that show that this drive was compromised? No, there aren't other stickers. So kind of curious that someone has obviously been inside of here. There's a date code on the side of the hard drive I see, and it says 8337. So the drive itself may not be as new as this. So maybe this was all, I don't know, like mix and match parts. So I'm not really holding out a ton of hope that everything's going to work, but I don't know. Let's start the diagnosis process. All right. So first, we're going to connect this up to my PC. Then got a green light. Let's plug in the power cable and switch on the drive. Luckily, the switch mode power supply underneath the board is nicely encased in a metal case. So it's not dangerous to have your hands inside of this thing while it's open, since the power supply is completely self-contained. Here's our ESProfile. I'm using Terraterm because this supports Z modem or X modem transfers. And this is our menu, version 1.0. Yep, and we're connected, 115,200 bits per second. So we're going to do get drive info. Let's see if this does anything. Now, I don't have the LED connected to the controller, so I don't know for sure if the light was just solid on. But the fact that this doesn't seem to be doing anything doesn't give me a lot of confidence. Oh, interesting. Some stuff came up. Seek error. Oh, okay. Command confirmation failed. Following data may be incorrect. Unrecoverable servo error. Widget only. Ignore for profile. Okay, yeah, timeout. So this did not seem happy. Device name. That's not working. Maybe what I need to do is connect the top cover light back up so I can just see if it's doing anything. All right, so the ready light is just on solid, which I suppose is a good thing. Let's try reset drive. That did nothing. The ready light is just on solid still. I think what I'm going to do is I'm going to power off the drive and I'll power it back up again. I want to see if the ready light does that same blinky thing before. So the ready light, it's just off. Oh, okay, now it's doing that blinking. Oh, I can see the head stepper moving. On the side of the drive, there's a stepper, and it's doing stuff. Right, so maybe I'll just wait until the ready light is on before attempting to do anything. Yeah, there's a little stepper motor on the side of the drive, and it is currently doing stuff. All right, so that means that even with the profile, the ESprofile connected, that it does run through the diagnostic process. Okay, ready light is on solid. Let's do get drive info now. Oh, it returned. Oh, hey, that was the trick. So raw data is that. Status looks good. Excellent. Device name, weird. But it shows us a 5 megabyte profile. Total block 6,200. Don't know if that's correct or not. Bad block 0. Spares allocated 0. I wonder if this drive is just not actually formatted. Read block into data buffer. Let's try that. Enter the block. Wow, I tried typing 100. It didn't do anything. Huh? Okay, there's data. I don't know why when I typed it didn't echo anything. Oh, you know what? That's probably a setting in here. Maybe I need to have local echo turned on. Let's try that again. Read into data buffer. 10. Use default retry count. Return for yes, I don't know. Okay, well, the drive's reading stuff. That's cool. Why don't we do backup entire drive? I should just do this now while it's working. Drive is a 5 megabyte profile with 2600 blocks. Is this correct? I guess. Yes. Oh, return for yes. Okay. Start X modem receiver now. Transfer X modem receive. Profile dump. Okay, immediately failed. But there is Lisa bug, so we have some files here. Sony util. Okay. Great. Now I have to reset the profile or reset the terminal here, which, how do I do that? Reset terminal, there we are. Okay, well, what happened with the X modem? Send and receive. Wonder if there's a setting I need to fiddle with. I suppose one problem is, oh, you know what? Maybe I have a flow control set. Let's look at the serial port. Okay, X on, X off. I don't know if I should use one of these other modes, maybe. What's interesting now is when I do drive info, we actually see profile. I don't know why the formatting's a bit messed up. I wonder if there's an issue with this terminal emulator. I mean, my PC is fast enough. Every time I do this, though, this looks a bit screwed up there. I'll just do no flow control. Nothing seems to change there. All right, well, let's try back up again with these new settings. Oops, enter, receive. No, just immediately had a problem. Maybe it was one of these options down here. Ah, well, that was it. Okay, well, now you know if you're gonna use this program to transfer from the thing. I have no flow control currently enabled. I don't know if that matters or not. But I had to change that CRC option. I think it was checksum. I changed it to CRC, and that seemed to have done the trick. I assume this is gonna take a while. Yeah, I'll just, we'll come back once this is done. So it's been transferring away. It looks like it's transferred already 2.5 megabytes. That's half the hard drive. It does pause sometimes, and I hear the hard drive sort of reseek. So we have to presume that it's hitting read errors, which might corrupt the dump we're doing here. But on the other hand, just low leveling this drive, it's probably the best thing I can do to it, just to ensure that it will work. And I don't really care about what's on here. Obviously, we saw there was Lisa stuff on here, and it's going to have someone's files. And unless they have some really cool hand-drawn artwork we can recover off of here, I don't really want to recover people's personal files and data and stuff like that. There we have it. Transfer complete. 4.93 megabytes was recovered from the drive, and this is it. I opened it in the hex editor. Error. There's what we saw on the transfer. Pre-boot, Lisa bug 2, Lisa bug. Like I said, we can be quite sure that this was for the Lisa, not Apple III. Disk read error. About to boot. Press mouse button to continue. Booting. Loading monitor symbols. Okay. Well, there's no mouse on the Apple III, so yet more confirmation. Error messages, or not error messages, system text messages. Here's something interesting. There's a bunch of text in French. Could this be from the previous owner? There's a lot more above. I just don't want to show it in case there's personal information in there. But yeah, there was a whole ton of French text there. You know what? Actually, instead of reading through the contents, we'll get back to that in just a sec. There's a command where we can read the entire drive. Let's see here. Show command status data buffers. Drive tests. Let's look there. Sequential read. I was reading the documentation while it was doing the X modem transfer. And what this does, loop test forever, enter for no. Okay, here we go. It's going to read the entire hard drive, and it will list out any of the read errors that I suspect there might be, maybe, because I heard it reseek or seek again while I was doing the X modem transfer. So I'll let this run, and let's look at the hex dump again. It says you can use an image writer or image writer 15 printer in either Macintosh or TTY mode. Macintosh mode. All right, and I did a bunch more scrolling through, and there's absolutely PII on this hard drive. I saw a lot more French, but I saw English as well, and I saw Oregon information with like Oregon local phone numbers and addresses. So without a doubt, this hard drive is filled with letters and stuff like that. And it looks like down here, though, it looks mostly blank. So there was a good amount of stuff on this hard drive. All this is blank down here, but it starts becoming filled with data just a little bit above here. So I'd say the drive was probably 75% full or 80% full at least. Quickly scanning again through it. Sorry, I'm not showing any of this. I could see there was like definitely coursework on here. Like there was a, I was talking about Thoreau and stuff like that, and history. There was a bunch of history stuff. And I saw Portland, Oregon addresses on here. So yeah, it's locally, this hard drive was used locally by someone who owned a Lisa. I wonder what happened to the Lisa. I wonder who these people are. I always wonder about this stuff when I get these old computers, the history of it all. And that's pretty fascinating to me. And probably what I'll try to do is when the Lisa's up and working is if this thing has, you know, a working image that's not corrupted, it'd be pretty cool to actually try to see if this thing boots the Lisa. And then also maybe I can, I don't know, figure out who owned this thing at some point and maybe reach out to them, and maybe they're still alive. That would be kind of interesting. At the same time, that might be kind of creepy and they don't really want to know about their old data floating around out there. Incidentally, back on the read, we do have some errors. Okay. So kind of tells me that I wonder, yeah, this thing's going to need a low-level format. There's a good chance that these errors will corrupt some of the files or potentially some of the operating system. Now I do have, I'm pretty sure I have an extra parallel port card. It's a interface card that goes in the Lisa and adds 2 more parallel ports. That would allow you to plug in multiple profiles at once. So I could emulate one that would boot the system off the ESP32, and then this thing I could then plug into the extra ports. So, you know, a corrupted OS won't keep the computer from booting, but I should be able to maybe access some of the files and stuff like that. Okay, yeah, here's our final list. It's not a ton of bad blocks, but we definitely have some. Okay. Now, the funny thing is, when we did the X modem transfer, I'm looking for where that is, it never asked about retries. Because it is curious, you know, I think there was an option for me to continually read a block over and over again. So let's try 750. You know what I should do first is save this list of bad blocks so we have it handy. Because I'm curious, if we do the repeatedly read block 3, 750 was one of the bad blocks. I'm curious if it, oh, it works sometimes. Ah, so this is a bit of an annoyance because with the X modem transfer, if it just retried over and over again, maybe it does. I'll need to reach out to Alex because maybe it tries its best to get a good transfer. Yeah, it seems to kind of fail every other time, which is odd, isn't it? Yeah, literally odd. 11, 13, 15. So we try a different block. Let's try reading 21E8 because I want to see if this one also has that same behavior where it's like every even write doesn't work and every odd write it works. I sent a message over to Alex just asking if the X modem transfer does do retries until it gets a good read, or how that works exactly. So 3, we'll paste that. Here we go. No, this one is, wow. So this block is a lot more reliable. So 5, 7 fail, 10, but then like got a bunch of reads out of it. Okay, let's pick another random one, 11 CD. So 3, paste. So the odd reads don't work and the even reads work. What a strange symptom. Okay, we're gonna try a different block here, 12 CD. Same freaking problem. Weird, very weird. Perhaps what we can do is take a look at the source code, maybe at that X modem transfer, and then we can see how this works. This looks like the routine. Backup errors, 0. So this is the X modem routine. I don't think this does retries necessarily. success packet. Now the interesting thing is, I'm quite sure it did not have this error. Some, certain amount of, it obviously says warning, certain number of errors, disk errors were encountered, like 5 disk errors or whatever. I don't think we saw that. Now, again, the reason why I thought there were errors because as it's reading blocks that are not working, the head reseeks, it like goes back and forth. And I heard it doing that during the X modem transfer. And hitting the scrollback buffer, it just says X modem transfer complete, which is right there. So that's, if there was a failure, then print the failure message or print complete, which is what we got. So that sort of implies that those read errors were not a problem. I just don't really see anything about the retries here, unless whatever command it's using to actually read those blocks from the disk actually does a retry, like the controller of the drive does the retry automatically. It just says read 2 blocks. Drive size 0, drive size 1, drive size 2, current block +2. All right, so one thing about the code is it's looking at the variable backup errors. If it's anything other than 0, that's when it's printing the message about problem reading from the disk. The thing is, I don't see where this particular variable is ever getting set to anything but 0. So it gets initialized to 0 right there. And I think this is the backup routine, yeah. And basically, it never looks like that variable is called to do anything. There's a procedure. Okay, wait a second. Here we go. Here we go. Read 2 blocks. All right. So this is where it would potentially set that variable. So it looks like handshake success, profile handshake, byte command response, send commands, blah, 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 blah. So Alex does appear to be checking the drive status between like each block read and then looking for errors. I mean, I'm no expert in software development, so this is my best guesses here. Yeah, it looks like it's reading and then full address sets the color of the thing. All right, well, that makes me feel a bit better that this variable was not set during our backup because we didn't have any of that failure message. So I presume we have a good backup. So I guess the question is, should I low level this drive and then I could just restore this backup back onto it? Because I think the low level will make the drive more reliable. You know what? I'm just going to do that. We have the backup. I can try to, use that on the profile emulator if need be. And if some of the data is lost or corrupted, oh well, whatever. Okay, you know what? I just got a message from Alex. He suggests running the full backup 2 or 3 times and then maybe combining the backup into one. We could diff the backups as well just to see if they're even different. Maybe they're all going to be identical and then we don't have to worry about it. But Alex says on my phone here, yeah, the backup process does not try to do retry. So it doesn't check the status of each block. I mean, it obviously does at some point because it could set that error. Very interesting. But the funny thing is Alex just said that perhaps he should add the retry feature to the backup thing, just for people who have read errors like this drive does. Okay, with that said, we'll do another backup. I'll do 2 more backups, backup entire drive, and then I'll do 1 more backup and I'll diff them. That way, obviously, if they're different, even with just 2 backups, if it's different, then dump. Okay, here we go. So CRC and binary. So if these 2 dumps, when I diff them, are identical, then I don't really need to worry, I think. Yeah, I think that's pretty safe. Okay, transfer is done, and yeah, no errors. So let's do that diff. Okay, we have profile 3.dump and 4. That was my 3rd and 4th attempt. And this has a nice data comparison functionality. Uh-oh. So that's interesting. It looks like there are only 2 bytes which are different. Next difference is F6. So it's 61 versus 60 and F0 versus 50. That's it. No further differences. All right, I guess I need to do a couple more of these dumps just to make sure that we're not getting any other random data mixed in there. Okay, here we go again with the next dump. All right, our 3rd transfer is complete. I accidentally named it profile6.dump, even though it's 3, 4, and 6. I think this can only compare 2 files. Right, okay. Well, I guess we'll do 4 and 3 first. So there's our 2 bytes. And that's it. And now we'll do 6 and 3. Ah, that had a single byte that was different. Ah, this is confusing. So that tells us that 4 and 6 are going to be different as well because those other bytes aren't different. Right, so 6 had 61 and F0 at that location. And then this other byte that's different as well, 73. And comparing again 3 to 6, the only difference is this one byte. That's 70 to 73. Very interesting. Very, very interesting. I'm torn between doing one more backup or just going with the 3. Yeah, I'll just do one more. It doesn't take that long. Backup entire drive. See, because it'd be nice to actually have 2 of the backup files that actually agree with each other, that have like no bytes that differ. But I kind of feel like every time we do this backup, we're gonna have just, you know, a couple bytes that are different. Okay, the 4th backup is done. It completed successfully as well. I put them all in this one folder. Let's take a look at 4, and I'll open up, I don't know, how about the first one? And let's do the data analysis, data comparison, that is. So there's the 61 and F0 that was different on, I think, the 2nd backup. Okay, we have another byte that's different. Wasn't 70 the one that was different as well? That's it. So very, very minor differences. Why don't we open up, let's see, the most recent backup. So 3, and I think that's 4. Let's do compare. Yeah, 3 versus 4. Let's see what we got. Okay, so that one byte, and there's that byte, 70 versus 73, and then that one. Okay, so the differences are minor, and hopefully that stuff is all like in the middle of a file, like not OS file, but just someone's Word document, or document that is. So it doesn't really matter if there's a misplaced letter or whatever, but I think hopefully with these 4 backups, that's enough to reassemble this into like a working system. Just because it's curious. And in my chatting with Alex just now, Alex would like to examine these backups just to see if there's any like lost drivers or anything else that's LOS related that maybe was never archived. Now, which incidentally, I just put these 4 dumps into a single 7-zip, maximum compression, 1.2 megabytes or so, 1.3 megabytes from 20. Okay, well, I think what we need to do is I want to low level this drive. I'm done making backups. So let's go to Profile Commands, H. It doesn't look like you have a diagnostic ROM fitted in your profile, which is needed for all the commands in this menu. Oh, I didn't realize I needed that. I just popped the cover off the drive and I'm looking. I don't see a ROM on here, so let's go back to the GitHub repo so I can see what I did wrong. 5 megabyte profile diagnostic commands. In order to execute any of the commands in this menu, you must have a 5 meg profile with a 2K or 4K ROMless Z8 that's fitted with the LLF version of the 5 megabyte profile ROM. A standard profile Z8 processor with the built-in mask ROM can't execute these commands. When attempting to enter this menu, it will detect that it doesn't have the proper ROM and will warn you. If not, you can find the firmware both of the standard and LLF for both the 5 meg and 10 meg profiles here. For the 5 meg profile, you can burn this into a 2716 or a 2732. Oh, profile stuff on bit savers. Okay, well, first of all, that's extremely annoying how I hit back and it didn't go back to where I was reading on the repo. Oh, what is this, like 1996 here? Okay, so this is the profile hard drive. This is going to be that Z80. Now it's completely got a Signetics part number and an Apple part number on here, 3410171. There's this IC, a D8253C. Is this a mask ROM? No, this is not a mask ROM. This is a NEC, well, yeah, it's an NEC part number, independent programmable multi-modal 16 counter timer. That's what I thought. So there's clearly, maybe there's a mod I would need. Oh, that's interesting. I just noticed here that someone has painted over a couple exposed traces. Very interesting. I looked up the Apple part number that's on the CPU, and it was found on here. It shows up as this, RWZ80 ROM version 3.98. Yeah, 341.071A. And sure enough, looking here, there's 341.0080 Z8 version, different firmware with a ROM built in. I found this really low-res picture of a profile hard drive controller, and it does look identical to this one. I mean, I could just make it out. It's got the same situation going on with this NEC chip down there, this one right there. And here on Old Crap, there's also one. Oh, this shows the missing plates that I don't have. Right. Oh, there's the profile hard drive sitting under the Apple III. Yeah, very nice. And the guts for it. And this drive, it has a slightly different revision. It says 656.102, same. Mine has an N there. And the difference is, let's see here. I don't have an IC in that spot. I have a crystal oscillator. And this seems to be, the oscillator is like that IC in that separate little crystal there. Down here it says B, and mine is a D, like Delta. Same version of the CPU though, I guess with the built-in ROM. All right, with that, I guess I am unable to low-level this hard drive, not without figuring out how exactly I can get this diagnostic ROM onto here. And my presumption is there's a version of the CPU you can buy, the Z8, a ROM-less version, which uses an external ROM, and maybe with a little interposer board that sits under the CPU, you plug in the Z8, and then you have this little ROM that's off board that will allow you to run the custom firmware to do this low leveling and stuff that I am unable to do because I don't have a Z8 CPU with the ROM-less version, and especially the interposer board. That's the only thing that really makes sense to me about this whole setup. Perhaps all I need to do is restore the backup I made of this back onto the drive, and maybe writing to the drive is enough to get it to stop erroring out. Although I doubt it. I'm probably going to have to low level it, and yeah, I just don't really see a way how to do that right now. I'm going to give this a little bit of thought, and then I'll come back. All right, so I've done a little bit of reading, and what the GitHub repo is talking about with the Z8 is there was a version that came out when the Z8 was released that had a piggyback ROM socket on it. It's pretty rare. I've never seen one, but I did look online and I saw one recently sold on eBay, pretty cheap, like 25 bucks recently. Well, recent as in September, so not that recently. Yeah, here it is. Vintage Lear Siegler ADM21 computer terminal. So it's the 8603. That's the part number for the 2K version that would be needed for this profile. And if we take a look at the photos from this listing, there it is. So it's a Zilog part, and then it has the extra ROM socket on it. Now, reading the technical manuals for this particular part, what they did is they brought out all of the control signals normally used for the internal ROM, and they brought them external. It allows you just to use an EEPROM. So chip select and the demultiplexing of the address and data bus lines, all that stuff is handled by the chip itself. And there it is, closer up. 8603 2K. There's a 4K version as well. Either way, these, while not expensive, they're pretty rare. There are none for sale right now. And while there's a normal ROM-less version of the chip, it's called the 8681, it does not bring out all of those chip select lines and all the demultiplexing out of the chip. So I'm pretty sure that the 8681 would work if you had an interposer board that had the chip select lines, or chip select logic along with the demultiplexers, like you needed latches and stuff like that. Because obviously I think the data and address lines on this chip in this version are multiplex. So data address on the same pins, and you got to latch it and stuff like that. This talks about that, but yeah, it's not as simple as just soldering on a socket onto that particular chip. The 8681 is very common. You can get them for like $5. But obviously in this particular circumstance, that's not really going to help me. The version that has a built-in ROM is called the Protopack Emulator, so 8603, and it sort of talks about the detail here. So what that really means is without this weird Protopack one, there's no way for me to run the diagnostic firmware, and therefore there's no way to do the low-level format. I might mention to Alex that perhaps in the GitHub repo, just mention and reinforce the fact that you do need this very rare version of the Z8603 chip for this machine, and that they're not common. So being able to do this low-level format isn't quite so easy. So with all that said, maybe I could just do this write zeros to drive. I'm sorry, I'm looking around my camera. Let me move this out of the way so I can see the screen face on. Yeah, why don't we do option 9? Because we can't do these. And drive test was more for the servos. Yeah, I think that's really it. So let's just try 9 and let's see what that does. And this will destroy the data. Yep, that's totally fine. Return for yes. Number of blocks. Okay, here we go. It's doing the full format. I'm just kind of hoping that maybe writing to all those blocks might somehow solve these read errors, although I'm not really confident. Ultimately, the low-level format is like the structure underneath where the blocks are written to the drive. Therefore, if there's something wrong with that underlying structure, it means that the servo and the circuitry in the drive just has trouble finding the exact blocks. So even writing all zeros to it isn't necessarily going to fix anything. There's no errors reported, but I just heard it have like a retry in the write process. Because this is writing commands to the controller to write to the drive, so it probably has some type of a verify operation that it's doing. And yep, I don't think this is going to fix anything. This is unfortunate. So I suppose if anyone's out there watching and you're good at the Z80 architecture thing, maybe you can design the interposer that could sit under the Z8 ROM list, the common one, and then add the 2K or 4K ROM, maybe with selection jumper, for people who need to do this type of work that I'm doing here, so they can use the commonly available Z8 ROM list versus that weird proto-pack one that is not something you can get. Because I think until that point, this drive will not really be particularly usable. Luckily, it doesn't really matter. I have the emulator, so I don't really need this profile to work. It just would be nice because it's period correct, not to mention this profile is capable of running with my Apple III, and right now the emulator is not. And I would like to try this on the Apple III and get that all set up properly. Incidentally, I found this on Wayback Machine. This was a project someone did to basically replicate this piggyback version of the Z8. I can't get a higher res picture there, but I think the whole idea was that if the Z8 processor on the profile fails, your whole system doesn't work anymore. So this is a useful way to get it working because, of course, those ROM dumps were available. I think it was on BitSavers, but I'm not even sure that this will fit inside the case with this development one installed just because it's tall. But it looks like this person created an adapter board that allows you to use a different package. It's something called the MME ROMless single chip microcontroller, the U882 and 884, which happens to be identical to the Zilog SGS piggyback devices. However, they have a flat package and a PCB is required to connect the EEPROM. And if we scroll down, there's a photograph of it. So this little PCB does fit in the profile because look, there it's being used in a profile just simply to replace the bad CPU, not necessarily to do this diagnostic stuff that we're doing here. But I do have to wonder if this MME part is hard to find. Looks like they were Soviet Union. Ah, okay. So here is the same company, MME's Z80 clone. Okay, so these parts are also not easy to find. Oh no, I stand corrected. I looked back at the posting, UB8820M. That's the version, the 2K one. There it is. So they're inexpensive, but not because, of course, shipping them into the US, unknown import fees, it would be $50 probably to get one of these. So it doesn't really make sense to order one because not only is delivery expensive, but these additional import fees you could hit with like $50 processing fees and stuff like that. But these do exist. So that's interesting. Yeah, that different package. So this seller has a whole bunch of them, and this is in Romania. I still feel, though, with the regular ROMless chip, the actual Zilog part, theoretically, with just some additional logic, I think you should be able to obviously make an external ROM. Like I said, looking at the technical documentation, that's how it's designed. It has no internal ROM. Well, there were two versions. Which one was it? So the ROMless 8681, that's the version. The 8682 has a little tiny bit of built-in ROM, so that one wouldn't work. But the 8681 has no built-in ROM. And therefore, I think it's completely appropriate to have this external ROM just with additional logic to support it, because that's how it was designed to be used. And when I look on eBay, like I said, these are like $5 and commonly available. So I think it'd be possible to design the PCB to hold one of those. Just is beyond my ability. I just don't know enough about how all that stuff works. All right, well, there we go. We wrote all zeros to the drive, but I have a feeling if we try to read the drive now, if we go back to our list of bad blocks, well, we know this one was definitely bad. Let's put this in, and I'm sure this will give us the same problems. What am I doing here? Oops, I did the wrong thing. Oh, well, that did come back all zeros at least. I'm sorry, I think we should have been in drive test. So a sequential read. There we go. What's amazing about this drive, it's been running for a while now, I don't know, hours, and it's just barely warm to the touch. That's pretty cool. This whole thing runs very cool to the touch. The power supply, it's kind of warm. Hey, 750. That was one of the errors, and it went right by. Well, I'll be. Maybe what we did here is enough to make this drive usable. Possibly. It's also possible that when it's all zeros, it's unable to detect CRC errors. I mean, you would think it would still be able to detect them, but maybe not, just due to the error checking routine. And that is why this is passing. You know what I'm wondering? This profile drive uses this Z8 microcontroller. I wonder what kind of hard drive is in the Apple 20 meg hard drive that was for the Mac 512, the one that plugged into the floppy port, because that has some kind of a CPU in there that basically makes it emulate a floppy drive. And I wonder if it's also the same Z8 or if it's using some other CPU. And I wonder like how similar it is to the profile architecturally. Like, did they take this board and adapt it to work on the Macintosh? I've never looked inside one of those. I don't have one of those, and I know the floppy EMU could just emulate it anyways. So it's, you know, there's no reason to have one of those flaky original drives, but it's just kind of curious. And we're 90%, and there is no errors. So I think when this is done, what I'm going to do is I'm going to upload using the X modem transfer. I'm going to upload a new image onto this drive. I'm not going to put the restored image. I'm just going to put a brand new Lisa or LOS image onto it. Alex sent me some. Actually, there's some on his GitHub repo, so I have some of those. Look at that. No errors. I'm shocked. Okay, well, yeah, like I said, so let's do restore drive from backup, D. This will destroy. Yeah, that's fine. Hit enter. Okay, start your transfer. I'm going to put 1K on because that's what it seemed to be using. And I'm going to upload no serialization on apps Lisa OS 2. That's what I'm going to start with. And let's see if this works. No. It does not. Okay, let's try that again, and I'll turn off that 1K. So we're going to do a restore. Enter. Enter. Send. Uncheck this. And no serialization on apps. And the reason why is, oh, this doesn't work either. So the reason why the no serialization is because there is DRM on the Lisa. I showed it in part 2 when I was at Alex's place and I tried to use my CPU card and it actually failed because apparently there's some serialization. I guess this is not compatible with TerraTerm's upload. We'll try one more time. X modem send 1K. I don't know, let's try another random thing. How about this one? Oh, that one's going. Well, that is odd because it's literally exactly the same as the first one. Can I cancel out of this? Yeah, unfortunately, the menu did not come back. So time to power cycle again. Okay, D. Okay, here we go again. I wonder if the problem is the file name. I don't think X modem actually transfers the file name, but just in case, we'll make a copy of this. I'm going to call it LOS2. And we'll hit open. And that did not work. I don't understand. The image is the same. At least that one canceled out. Restore. Send. Let's do it again. X modem send. LOS2.image. There it goes. Weird. Okay, so it's just a little unreliable. It should work this time. I decided while it's doing the upload, take a look at the hard disk 20 for the Mac Plus and 512. This is the one that's floppy drive connector, 500 kilobits per second. It contains a RODIME hard drive, so it's not SCSI or anything like that. So because the Macintosh needed to be a true business computer, but it had no hard drive when it launched and no capability of it, Apple's introduction of the hard disk 20SC, the first SCSI drive they manufactured, they didn't make the hard drive, by the way. It had like a Seagate drive inside. It's just they made the, the case and they put it all together. The HD20 was Apple's only Apple manufactured hard drive available for the Macintosh except the Mac XL, talking about the profile on the Mac XL. The HD20 was not compatible with any other Apple computer or other platform. So yeah, the Macintosh Plus came out in '86, and that of course could use SCSI, and there were other SCSI hard drives, so that was clearly a better choice. Some companies offered a SCSI conversion kit which replaced the hard drive controller, preserving the user's investment in the expensive but proprietary RODIME drive. Apple officially dropped support for the HD20 with System 6, as well as omitting necessary ROM code beginning with the Mac 2. I think the Mac SE can boot those hard drives, I think, and even the Classic potentially, but not the Mac 2. Sales of the HD20 continued to support the Mac 512KE, which had no other hard drive option, unless it was like a third-party one, which did exist, until it was discontinued in late 1987. Actually, what's interesting is there were absolutely SCSI port add-ons for the 512. So you use the Mac Plus ROMs in it, which is what the KE is. It's a Mac Plus ROMs. And then the interposer under the CPU adds the SCSI controller chip and a way to connect it externally. And I guess the select logic or whatever just emulates the way the Mac Plus SCSI controller is, like where it exists in the memory map. So it just works. So that did exist as well. I was hoping we could find some more info. Maybe here's some. Like I want to know about the hard drive. The following Macs are not compatible. Oh, okay. So yeah, SE Classic 2CI portable. Oh, they all support the floppy drive hard drive, but oddly not the 2 and 2X. Why would the 2CI support it, but not the 2CX and 2X? These are older. That's funny. And even the Mac LC. And it's true that certain models of these actually can boot this hard drive as well. And it says, if you plug the HD20 and a SCSI drive into your Macintosh, a valid system folder on the HD20 will cause it to boot from the HD20 and not the SCSI drive. Very interesting. Okay, well, these tech specs, they didn't give us any info. It's still transferring on X modem, so I still have time to look around. Apple HD20 controller. I don't know what to look for here. Here we go. Yes, bit savers, of course. There it is. Nice. I see a Zilog chip. 3410339A. That's probably a ROMless chip right there. Yep, that's SRAM. Some ASIC. ROMless. It uses the IWM. Well, that's fascinating. Oh, it does have a ROM though. Very interesting. So it uses a ROM. It uses the IWM. It's a 0041 as well. So if you have a broken hard drive 20 and it's like totally dead because the original hard drive is gone, please make sure you steal the IWM out of it. This is a very worthwhile chip to have. Socket it or whatever. Because yeah, the problem is this RODIME drive that's in here is proprietary, the way it connects up, and I don't think anyone has an emulator, so there's really no way to, I don't know, get this thing up and running. It doesn't really matter. You can just use one of those floppy emus. They can emulate this thing anyways. And I think there's other stuff that can emulate it as well. But the fact that it's got an 0041 IWM in there, absolutely worth saving. Let's see if we can figure out what the 341 0039 is. 0339. 0339, okay. Apple. It does not appear to be documented because there's 341 0344. It's 339. 339? There is no 339 on this document. Okay, well, the fact that it's a Zilog part number, though, 3410339, the fact that it's a Zilog part number, it's got to be the Z8 again, probably the ROMless version, and then we have an external ROM, and then we have the IWM and SRAM. And of course, what's funny, actually, the Z80 or the Z8 ROMless has built-in RAM, but it's a very tiny amount. So I suppose it just needs more to run the whole disk emulation using the IWM. And then whatever this chip is, 344 0600, nothing down here either. Just making sure it's 344-0600. And yeah, there's nothing. Nothing. Very interesting. I'm looking for this. It like tries to look up phone numbers and things. Yeah, there's nothing coming back on the internet about the various chips that are on here. But anyways, yeah, steal the IWM. Definitely steal the IWM. It is without a doubt very worthwhile chips to take off these. And look how there's an extra connector there. It's almost like they had intended to put this internal to the machine, because that looks like the standard floppy drive connector used on the internal 3.5-inch floppy connector. Because of the architecture of this, there is no reason why different firmware wouldn't result in this drive working on an Apple IIc and a 2GS as a smart port drive. Absolutely, without a doubt, it would just need new firmware to work. I'm just looking at what else is on BitSavers. So yeah, 341.00339. So as I said, almost certainly this is like an internal floppy drive connection. Very, very interesting. Got a PAL there. IWM, mask ROM, 2764 compatible. Almost certainly a Z8 ROMless chip, SRAM, and then this chip here. There's a disk image of a diagnostic floppy. Another copy, another set of pictures. Oh. 341.0339. Okay, still a part number we can't decipher. Oh, the PAL's been decoded as well, or at least the pins have been documented. Hold off, reset. There are those phase signals. And there's the Rodime hard drive with the weird interface. I know I've seen some of these working before, some of these drives working before. Just trying to see. Got another Z80 on here. Is that another ROMless chip? Probably another Z8. Very, very commonly used. Okay, there's also dumps of the firmware. Oh, there's the JED for the PALs. Wow, that's freaking awesome, to be honest. So different copies of the firmware, 8K firmware, and here's the disassembly of the ROM. I don't know, someone could look at this and probably know exactly. Oh, did it say up here what? Oh yeah, Z8. There we go. Confirmed. Okay, our backup has been restored. I think what I want to do now is we'll just do a sequential read, and we'll just make sure that this does read the disk without any errors. And I'll go back to looking at this other hard drive here. So look, someone disassembled it and reassembled the firmware. What's surprising is that this reassembled with all of this. What's going on with this? All of these bytes? That doesn't make sense. It's almost like there's an offset problem, but maybe not. Anyhow, with some smart programming, someone who knows Z8 code really well, and the IWM, like I said, this could be turned into a smart port hard drive. How cool would that be? I almost feel like Apple, probably was thinking about that, because the Apple IIc would have been out at the same time as the Mac, as this hard drive. I think it came out in '85. And, it could have been the hard drive for the IIc, made it more like even more businessy. But Apple never released anything, even though all that functionality is there. SmartPort is quite capable. It does a lot. When you hook up the FujiNet, you can get like network connectivity across it, like emulation of CPM across it, and do all sorts of awesome stuff. And things that were never used is all there, and yet Apple just implemented it and never did anything. Software Protocol for Directly Connected Disks by Michael Hanlon. So it looks like 7 for 8 transmission. We get 7 bytes of data for every 8 bits transmitted. In order to support hold off. I wonder how similar this is to the smart port stuff. Anyways, this is an entire description of the protocol. Okay, looking back on the hard drive, read test. So our block 750 still gave us a read error. I just made a sound for like rereading the block. It didn't give an error though. Interesting, very interesting. So everything read except for 750. I wonder if it's because the drive is mostly empty now, because it doesn't have anything on it except for just the OS, which is going to be in that section of the disk at 750. Let's do repeatedly read, and we'll do 750. And I'm assuming we're going to get the odd problem again. Yep. Same issue. Yeah, like I said, I bet you the problem is those other blocks are just blank now. I think we can actually do this. We can read a block So if we read 750, which we know is one of the problem ones. Okay, so yeah, I don't know if that's right or wrong or not. I guess we could actually compare this to the disk image I have on my hard drive. But what I can do is we can just look at one of the other blocks that's bad, like 4AD, the next one that was having issues reading. And let's read that into the buffer. And let's see if it's blank or not, like my hypothesis. Oh, it's not blank. That's interesting. Okay, why don't we do a repeated read on that? So that would be drive test G3, and let's try that. So that one works. Very odd behavior, this drive. I'm curious to try this next block here. Repeatedly read. Okay, it's reading with no issues. So let's go back to the main menu and let's read this into the buffer. No, it's got data too. All right, well, what's so weird? Why is 750 the only one having issues and everything else working? I don't know. All right, well, this second channel video has gone on for long enough. I know that this has hopefully a working bootable image that the machine should be able to boot into, LOS2, but obviously the emulator has all these drive images onto it as well. I already copied them on the SD card, so I'm good to go for booting. If you have any thoughts about what I might be able to do about this drive, like how to low level it, how to fix that 750 that it's getting, or maybe I just need to write this image a few more times and that will fix it. I'm not quite sure. And you know what? I'm changing my mind about ending this video because I think we have repeatedly write block here too. Let's just do that. Maybe if I just repeatedly write to it, that'll fix it. Yeah, I mean, look, it had one error. Sparing occurred. Oh, sparing. Was that the controller remapping that sector or that block? I bet you it was. Oh, very interesting. So there must be some extra blocks on the drive available for this, and it has remapped them. It just didn't remap that drive or that one. Let's repeatedly read 750. Yeah, look, it's working now. So my assumption is it's actually reading this from somewhere else on the disk now. Very curious. So all I need to do is just write that image back on the drive, and I guess it's good, and all those bad sectors that exist are just not going to be used because they've been spared, as in it used spare blocks. There's probably a table somewhere that the controller uses to map out the bad sectors. Okay, cool. All right, well, what I'm going to do is I'm going to do the restore one more time, and hopefully I can actually get that started since it was flaky at starting. So LOS2, okay, it's going. Sweet. And now I think I'm going to end this video. So yeah, there we go. That was playing around with the profile hard drive, and it seems to be working other than these bad sectors. If you have any thoughts about how I might be able to get this diagnostic ROM running on here, I'm sure a low-level hard format and surface scan will probably correct a lot of the bad sectors, but it seems that there aren't that many. Remember, there was only 10. I counted them up. There were 10, and there's enough spare blocks in the drive somewhere, unused cylinders and stuff, to be able to mark them all as bad. And I think the drive is going to be fully operational at this point, which is awesome. So I got to thank Alex for coming up with this little ESProfile device and all the work that's gone into the scripts and the diagnostic utilities, because this has been extremely helpful. Now I'm confident to know that this profile drive is working. And the good thing is I was able to get hopefully a good enough image off of this drive that maybe there's some data from LOS that was on there that could be great to be archived. So I'm going to send those images over to Alex, and I asked him just to be careful with them because, of course, like I said, they have PII in them, and I don't want that stuff floating around on the internet. And otherwise, yeah. So it's been kind of fun, and well, two things. I'm really glad to know the ESProfile works. So that means when I get back to the lease, I'll be able to plug it in and get that thing booted up. But then B, this profile drive, as old as it is, and it looks like someone took the screws off and it's all a mishmash of parts, does freaking work. How cool is that? So that's going to be it. If you like this video, thumbs up. If you didn't know what to do, huge thanks to my supporters. Names won't go on the screen, all usual YouTube junk. And that's going to be that. That's going to be that. So stay healthy, stay safe. I'll see you next time. Bye.